Today we're going to explain arithmetic and geometric sequences, and first of all we need to know that a sequence is an ordered list of numbers that shows a pattern. An arithmetic sequence always shows a pattern, and in the pattern shows the sum or difference in the sequence. The formula for the arithmetic sequence is an that equals a1, that is the first term, plus parentheses n, the number of the term, minus 1, parentheses, and the difference between the numbers. And we wrote two examples. The first one is 2, 5, 8, and 11, and it shows a pattern of addition of 3. And you can simply only add the 3, and it will give a 14 to find the other term. But if we need to find a longer term, like term 52, we can use the formula. And in this exercise, we can see that it has a difference of 4. So it is subtracting 4. To find the next term, we're going to use the formula. So 14, the first number, plus parentheses, the number term we are looking for, that is the fifth. First, second, third, fourth, and we're looking for the fifth. So it's 5 minus 1, parentheses, and we multiply it by the difference of the numbers. And we use PEMDAS, and the result is -2.
Well, now we are going to talk about geometric sequences, and it also shows a pattern. In this case, the pattern is a multiplication, which multiplies the previous term with a constant. We will see it in the formula. In the formula is the an, which is the term we are looking for, the a1, that is the first term in our sequence, the n, that is the term we are looking for, the place of the term, and the radio is the kind of the difference like we saw in the arithmetic sequence, and it's the constant. For example, I have here a sequence of 2, 4, 8, and 16, and we could see that each time the term is multiplied by 2, so we can say that the constant is 2. But what happens when it goes lower, in this case 27, 9, 3, and 1, you can say it divides by 3, but in this case it's the correct way to say the radio is 1/3. So if you multiply 27 times 1/3, it will give you the same as if you divide it by 3. So the correct answer is 1/3, the constant. Here we have a sample how we can use a formula to find a specific term in case you have a term that you find in a much longer sequence, for example 50. But in this case we will find a fifth term in the first sequence that we have. So first we have the an, which is the term we're looking for, then the 2, that is the first term that we have in our sequence. Then the other 2, in this case, is the constant that we have in our sequence, and we can see in the difference between each term, the 5 is in the place that we are looking for, in this case the fifth one, and the -1, it's in the formula. So you can simplify it with PEMDAS, and the answer is 32. The same way if you could have used the multiplication with 16 times 2, it will give you 32.